Hello, this is Todd Danielson, the editorial director of Informed Infrastructure. Today I'm talking with structural engineer Clark Bauer, who was recently featured in our April 2020 issue about hand sketching and how it can be used in a modern engineering and design practice. Clark, the article is about hand sketching. Can you tell me a little bit about how you learned to hand sketch?
I grew up in a time when if you asked an architect why he became an architect, he or she became an architect, they would frequently say, because I always liked to draw. It was very common. And I always liked to draw as a child and growing up. When I went to architecture school, quite a number of classes, both as adjuncts to the design classes we took, and just general art classes, there was a lot of sketching that was taught. And it was valued, and that was sketching all kinds of things, including buildings. And so I took to that. I enjoyed it a great deal, and as I continued to pursue that, I actually took a few independent study courses with artists to learn how to draw better, because I both enjoyed it and I thought it was valuable. So it started young, but then it went into formal education, and I've enjoyed it, and that's how the skill was developed.
Okay, so what are some of your favorite sketching techniques? Maybe something that you've learned along the way or something you've created yourself?
When we're traveling as a family and I'll be sketching buildings, I mean, then I'm using different kinds of pencils and with different weights, different softnesses of lead, and working with heavier sketch paper. When I'm drawing professionally, it's actually fairly simple. But one of the things that's extremely important for me to understand when I'm drawing professionally, to understand things, is to draw to scale. Draw as accurately as possible to scale. And it's very simple just to use graph paper and a simple Pentel mechanical pencil with a lot of eraser. So that's the most common thing. I use graph paper with a Pentel mechanical pencil, and that works.
Okay. So what are some of the possible limitations of hand sketching? Like, what if somebody's really bad at drawing?
I mean, certainly drawing skill helps. Drawing interest in drawing helps, and so I suppose there are some advantages to that. But you don't have to. I mean, you can draw, you can sketch professionally, you can sketch as a structural engineer without great expertise as a drawer. It's just a matter of looking at what's there and trying to understand it and draw it and replicate it appropriately. Limitations are there are a fair number of limitations. I mean, it's not fast. It can be. It can speed up the ultimate process of finding solutions, but it's not terribly fast. And if you're actually producing drawings that are going to be published or issued for permit or for construction, it takes some time to do that. And it's whereas with AutoCAD you can copy and rotate and do all kinds of things to speed up the process of drawing. And with hand drawing you don't have that. So there are some limitations just relative to actual production of drawings, but it's still a very powerful tool in terms of understanding the issues.
Okay, how might hand sketching be integrated into a modern design practice?
Well, it's interesting. I started my career at SOM, and the senior partner then was design partner was Bruce Graham, and he always said, if you can your concept is clear if you can sketch it upside down on a napkin in front of a client. So it's a powerful tool in design and in structural engineering as well. As I said before, in terms of using it as a means to understand and communicate the issues. There are a lot of ways to sort of integrate it, a hand drawing, and then it can be scanned and manipulated a bit to be incorporated in a set of drawings. So there are techniques that you can use in that regard.
What might be, with all of your experience, some advice you could give engineers and designers of how they can improve their sketches and use them in their practices?
A couple of things. One is I think it's important, first of all, to take your time. Sketching quickly can be useful, but slowing down the process and understanding what you're drawing is certainly important. And I think, especially if you're talking about structural engineering, it's very important to, as much as possible, draw to scale. That's when you really start to understand how things are fitting together and what you're doing, what you're going to do to interface with the structures that you're talking about. So take your time and draw to scale.
All right, thanks, Clark. I would love to see you sketch a little bit. Do you think you could kind of go through your process for about a minute or so?
Let me think of a good example. I mentioned earlier that it's the hand sketching. I find it's extremely useful in especially when you're working with existing buildings, because you need to understand what's going on. And when you work in Chicago, you work with a lot of existing buildings. So there was actually an old Nabisco factory that was constructed of structural steel and then clay tile arch floors. It had a train track that ran through, that the trains would pull through the building and deliver product to the factory. And it's no longer functioning as a factory, and they wanted to infill that area. So we needed to we took out the train tracks and we needed to infill the floor framing. So that was fine. You can infill the floor framing. But the one thing we learned is that the columns were actually cast iron. So we were going to infill the floor framing with structural steel, of course. But how do we connect at the columns? You can't really, the connection of the existing steel beams to the columns was all cast in place. We couldn't cast something in place, and so we needed to come up with some design that attached, where we supported our beam close to the column but adjacent to it. So part of that involved just understanding what was there, and just one aspect of that, there was a system of two beams that would cantilever out from a column, and we were going to go past those two beams and into the column, and we couldn't bear on the column. So then how do we could add a new column, but how do we support that new column? So we learned that through exploration, we learned that the two beams that were cantilevering out, where we were going to locate, those two beams were sitting directly on top of the foundation. So if we could just get our column to bear on the top of those two beams, we were set. That would get the load all the way down to the ground. So what we did is we cut out the concrete, we installed a steel plate, and then to which were welded anchor bolts, and then we sat the column down on top of the anchor bolts, and the plate on top of the anchor bolts, and then put the column on top of that. And then a side view is here. Here's our base plate, and then we welded anchor bolts to that, and then filled that in again with concrete, put the base plate on top of that, and there was our column. So, and then we also, just to help with the loads, we cut the slab out and we put a little rebar, put some rebar into the concrete infill, and there we have it. And so here are the steel beams that project out. We cut into the slab, we welded this bottom plate down on top of the steel beams and then that had the anchor bolts on top of that. Put the base plate on top of it, and the new steel column on top of that, which supported the beam which we were installing above. And then looking this direction down here are the two beams, and we welded that plate there. Infilled it with concrete, reinforced, laid down the plate, and installed the pipe column. So the thing was just, first of all, what is there? And then once we understood what was there, it was actually pretty solid, because these two beams were sitting right on top of a foundation. All we had to do is get a good positive attachment to the foundation, to the top of the beams, and we were good to go. So that would be one example.
All right, thanks, Clark. Shifting gears a little bit, how are you adjusting to the new working from home environment?
Well, actually, I have my own practice. I work out of my home. So as I've been telling people, I have self-quarantined voluntarily for the last 6 years. So it's not a lot of change for me, actually. But I do have additional people. We're a family of 4, and so my wife and our 2 children are here. So that's been a bit of adjustment for all of us. It's been a pleasant adjustment thus far, but that's a lot of my work is out of my home. Now there have been limits. Obviously, we don't. We're limited to how many different sites you can go to, and so there are some limitations. We're respecting the shelter at home and the social distancing and all those sorts of things, but the adjustment so far has been fairly smooth.
Okay, I've actually been working from home for 21 years, so I can relate. I've been trying to pass along some advice to people who are new to it. Since you've been doing this for a while, what might be some advice that you can pass along to the people who are newbies, just learning how to do this?
It's not really unique to me, but one of the things that's very, very useful when you're working from home is to still establish boundaries. I have a space that's my office space, and when I'm finished with work, hopefully at some scheduled time, which everyone in the family knows what that schedule is. In an ideal world, then I leave that space, and my work has been completed. So that's one of the things: create boundaries, so you know when you're working and you know when you're not working, because it's very easy to let it permeate everything. That's the main thing I would say.
All right, great. So what might be some of your favorite remote working technology tools, particularly for engineering and design?
Well, most of what we do is remote. I mean, in the city of Chicago, when you submit plans for permit, it's all e-permit. That the whole process is e-permit. We use a lot of things that might be somewhat outdated, Dropbox to share files, and certainly email. The structural analysis software that I have is subscription and cloud-based. So that's all that can be done from anywhere. I have occasionally in the past, before we were sheltering at home, just taken my laptop to a coffee shop and worked very happily there, just because you can connect in with Dropbox or whatever, or the cloud-based structural analysis package, or your Microsoft Excel worksheet, or whatever you can tap into. So it's very convenient in that regard. Working at home, given the technology that we have today, working at home is certainly can be much more effective.